It means that science, I think, has treated the field of cold fusion badly. Mainstream scientists associated with cold fusion were not allowed to publish in mainstream journals, and that means they would not be able to get paying jobs at mainstream institutions. They would not get research grants. They would not get respect of their colleagues. The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective on important societal issues.
Produced by Soapbox Media.
Hello, and welcome to another episode of The Rational View. I'm your host, Dr. Al Scott. In this episode, I'm reviewing the fine line between science, pathological science, and pseudoscience. In most cases, the line is not fine at all. There are, of course, many pseudo-scientific practices that are clearly not based on the principles of honest scientific investigation. And these include things like creationism, homeopathy, astrology, even flat-earthism. Some of these pretend to be scientific, but it's pretty clear in all cases that they exist not because of honest investigation into the evidence, but instead are based on faith or profit or some other motive. There are several beliefs or ideas, however, that are not so clear-cut and actually have some non-biased scientific support, although they may be verboten for members of the scientific community to investigate. I, in the past, have looked into electromagnetic hypersensitivity in a past episode. This is something that the scientific community in general disregards as good science. I came away unconvinced that electromagnetic radiation is causing the health problems of sufferers, but there is definitely something unexplained going on. And this means it's ripe for scientific investigation. So there's a problem. I want to explore in this episode the scientific community's response to a couple different, somewhat radical ideas and ask if the approach was rational and what the evidence tells us. If you like what you're hearing, please press like on your podcast app. Come join us on our Facebook group, The Rational View, and come take a look at my webpage, www.therationalview.ca. So the first idea I want to discuss, some of you may know, is the EM drive. EM standing for electromagnetic. Now, this is an idea that originally came to light in the early part of this millennium. For those of you who are listening in future millennia, I'm talking about the 2000s for reference to all of my distant future listeners. The EM drive is a cone-shaped metal resonator that's pumped full of microwaves, electromagnetic radiation, and is supposed to provide thrust without any exhaust. The EM drive was copyrighted by a parent company, SPR Limited, and theoretically, it works by trapping these microwaves in a particularly shaped chamber where they're bouncing off of the two ends, changes the properties of the waves, and produces a net thrust in one direction. The chamber is closed, meaning from the outside, it will appear to simply move without any fuel output or thrust output. The company SPR Limited explains as follows. This relies on Newton's second law, where force is defined as the rate of change of momentum. Thus, an electromagnetic or EM wave traveling at the speed of light has a certain momentum, which it will transfer to a reflector, resulting in a tiny force. Now, our best understanding of physics says that this shouldn't work. No energy is leaving the chamber, so momentum and energy are not conserved, and yet millinewtons of net force were measured. The company resorts to relativity to try to explain this effect, to confuse the listener. The first design of a resonant cavity thruster claiming to be a reactionless drive was by Robert Shire in 2001. He called his conical design an M drive, EM for electromagnetic, obviously, and claimed that it produced thrust in the direction of the base of the cone. Several patents were generated and several startup companies were funded to produce prototypes. As funding and results accumulated, it reached a point where other scientists started to take interest in these claims, especially when research results seemed positive. At this point, you you have skepticism, but you're willing to investigate the claims. In 2016, a team of NASA scientists and a parallel team in Xi'an, China, investigated and verified the phenomenon. They actually measured net thrust in these two experiments in other opposite sides of the world. And this generated a lot of excitement in the scientific community. Like, this is groundbreaking if true. You could think of rocket ships that could go forever without taking on fuel. All they would need is a nuclear reactor or solar panels. So this is when people started to take interest, when suddenly someone new, a new group came in and verified the results and showed, yes, we've measured the same thing. So now there's a lot more interest. There's a lot more, the skepticism has been knocked down a scale. But for extraordinary claims, you require extraordinary evidence. Theoretical physicists started putting out speculative papers about how the M drive might work without completely upending the laws of physics, which we've all grown to know and love. So following this initial success, in 2021, very recently, using a new measuring scale and different suspension points of the same engine, scientists were able to reproduce apparent thrust forces similar to those measured by the NASA team, but also to make them disappear by means of a point suspension. So what was happening was that as they were pumping all these EM waves into this thing, it was heating up and expanding in one direction. And this was the source of the force. It was expanding asymmetrically, and millinewtons of force were measured, and the original teams were a little bit sloppy and didn't notice this. Obviously, they would have expounded on the sources of error, and this is one of the sources of error that they mentioned, but they weren't able to rule it out. So follow-on work showed that this was just thermal expansion. The verdict, and this is from the research paper that finally disproved it, when power flows into the M drive, the engine warms up. This also causes the fastening elements on the scale to warp, causing the scale to move to a new 0 point. We were able to prevent that in an improved structure. Our measurements refute all M drive claims by at least 3 orders of magnitude. This is how science works. An outlandish, off-the-wall idea was proposed. Eventually, an independent lab was interested enough to test the idea. Finally, the weight of evidence from well-run experiments falsified the idea. In EM drives, huge amounts of power were being pumped in, and a minuscule amount of thrust was being measured. These types of claims and experiments are common and very difficult to measure with the necessary precision. Any sort of error in your initial power measurements, any sort of leaks or small fractional things, if you're measuring very small signals, can be easily mistaken. So this is, an honest mistake. They measured something exciting. They published the results. The results were challenged. The results were refuted. This is how science works. It kind of reminds me, actually, to a certain extent, of the time I was asked to review a company that was applying for a grant from the government, from a government department, and it was the company was growing was building algae growing bioreactors, and they were claiming that they would turn CO2 from smokestacks into fuel and create energy in the process. And I said, "Whoa, this is a wild claim. Interesting. This sounds great." So I looked into it, and they were asked me to review the grant application. They'd already received significant funding from government grants and venture capitalists, and were looking for millions more. And they had pages of calculations that supposedly showed these LED-powered bioreactors that would turn CO2 into algae, which could then be used to create fuel to power cars. And they were they had already built a small prototype reactor. They had a lot of high-powered executives and board members, but there were no physicists on the team. And the small prototype reactor, for some reason, hadn't yet produced net energy. And they believed that if they scaled it up to a larger bioreactor, they would get there. So I told them it wouldn't work. And the company asked to set up a meeting with their spreadsheet energy balance guru, and they talked me through the whole thing. And I just said, look, photosynthesis is inefficient. It captures less than 20% of the input energy into chemical energy. There are no other pathways to make that energy. So you are taking LEDs, which are, a certain percentage, less than 50% efficient, 30% or some 25% efficient, pushing it into photosynthesis, which is 20% efficient, you aren't getting back more power, more energy than you put into this bioreactor. They thought they would have the niftiest system in the world, since it didn't need to use huge, shallow outdoor growth pools like other algae growing companies did. But the reason they did that was because the sunlight was free. They didn't have to pay for the electrical power. And they were going to grow the algae indoors and continuously and solve the world's climate and energy problems. And, it was good on them to try that, but they came up against the problem that they're proposing a free energy machine, which doesn't work. So the next topic that I want to talk about is cold fusion. And this will maybe run tingles up your spine. And if any of you were around when it was announced, it was quite a stunning announcement. In March of 1989, electrochemists Pons and Fleischmann rushed to hold a press conference to announce a groundbreaking discovery that would revitalize clean energy production worldwide and save us from the greenhouse effect of fossil fuels: cold fusion. The circumstances of the announcement were surrounded by controversy, and this came out later, as there was apparently an agreement in place to submit their experimental results, simultaneously to nature with a competing researcher who was looking at muon-catalyzed fusion, which is a real thing. The allure of being the first to announce a new source of clean energy and get their patents accepted with their priority, seemingly outsmart the physicists who had spent billions on tokamaks and huge lasers, was apparently overwhelming. So they came out with this announcement. The infamous duo conducted electrolysis experiments using a palladium, it's a very expensive metal, a palladium cathode and heavy water. So electrolysis is where you put electricity into a cathode, between a cathode and anode, and it turns it splits water molecules basically into hydrogen and oxygen. So they're running electricity through this palladium cathode, but they're doing it in heavy water, deuterium dioxide rather than hydrogen dioxide. Deuterium is an isotope of hydrogen with an extra neutron. This is used as a moderator in CANDU reactors. And they were measuring the heat coming out of this electrolysis machine with a calorimeter, which is an insulated vessel which measures heat. It's got insulators, it's got heaters, it's got sensors. So current was applied continuously to the electrolysis system for many weeks, with the heavy water being renewed at intervals as it bubbled away. Some deuterium was thought to be accumulating within the cathode. Hydrogen has an affinity for metals and can, if you look at the hydrogen economy that people are talking about, metals are used as storage mediums for hydrogen, because the hydrogen actually goes into the metal and absorbs into the skin of the metal and even into the depths of metal. It moves through the metal. And that's why it's so hard to store, because if you put it in a metal storage tank, it just comes through the walls. It's such a tiny molecule. So deuterium, which is a form of hydrogen, was thought to be accumulating in the cathode as they were doing this, but most was allowed to bubble out of the cell, joining oxygen produced at the anode. For most of the time, the power input to the cell was equal to the calculated power leaving the cell within their measurement accuracy, and the cell temperature was stable around 30 degrees Celsius. So room temperature. This is why they call it cold fusion, compared to millions of degrees used in tokamaks or in laser inertial fusion experiments. So as they were bubbling away, at some point in some of the experiments, the temperature would suddenly rise to about 50 degrees Celsius without changing the input power. These high temperature phases would last for 2 days or more and would repeat several times in any given experiment once they had occurred. The calculated power leaving the cell was significantly higher than the input power during these high temperature phases. Eventually, the high temperature phases would no longer occur within a particular cell. This was the basis of their idea that deuterium was somehow being pushed tightly into the confines of this metal, and this storing it in the metal with the electricity present was somehow creating fusion, creating deuterium to deuterium smacking together to make helium and releasing oodles of energy. The nuclear energy of the sun was being generated in these metal cathodes. So immediately, several labs started attempting to reproduce the work. However, the experimental protocols were not available. So immediately, several labs started attempting to reproduce the work. However, the experimental protocols hadn't been published. This was a news conference. This was it. There was a news conference, vague idea of what the experimental protocols were. Most of the initial attempts to reproduce it failed miserably. Although there were a few scattered measurements of excess heat or fusion products, the vast majority were negative, and they were waved off as experimental error. Now, in support of their claim that nuclear reactions were taking place in their electrolytic cells, Pons and Fleischmann reported a neutron flux had been measured of about 4,000 neutrons per second. And this is a well-known side effect of fusion. High-energy neutrons come shooting out, as well as the detection of tritium had been announced. Now, classical fusion would predict that with 1 watt of fusion power, they'd be producing something like 10 to the exponent 12 neutrons per second, levels that would have been fatal to the researchers. And I remember this rebuttal coming out in the press, and it seemed fatal to their claims. Like, obviously, the deuterium-deuterium fusion they're claiming isn't happening. So a lot of the physicists tuned out at this point, right? This obviously isn't fusion. They're pumping a lot of energy over days into this cell. Maybe it's just some sort of chemical battery that they're making. Maybe this thing is bringing hydrogen in and then letting it out at some point, and there's a heating or a phase change going on or cracking in the palladium. Nobody really knew what was happening, but it certainly wasn't what they were claiming. Claims of deuterium fusion gamma ray emissions that had been measured were found to be erroneous. Maybe nothing was happening. Maybe it was a fake. Nobody really knew. With no scientific explanation and no consistent replication of the results, by May of 1989, the physics community had declared cold fusion as dead. After this point, journal articles for cold fusion were not being published in major journals. Despite these claims, a small community of independent researchers, entrepreneurs, and con artists pushed resolutely forward, holding annual conferences and publishing their work outside of peer-reviewed journals that wouldn't accept it. The most serious work was done in Japan, where they spent 5 years and $20 million in an unsuccessful attempt to replicate the work of Pons and Fleischmann. And that happened in the mid-90s. And that might have been the end of it. The problem is that these people were forced to publish in print fringe journals. They weren't getting support of the mainstream. And in a fringe journal, you're not going to get the sort of quality of peer review. Questionable results might be published. And because of the vast majority of people saying it's dead, they didn't want to criticize themselves, right? They wanted what they were doing to be true. So this is why a lot of people call cold fusion pathological science. And it's not necessarily the scientist's fault. There could have been very good science going on, but the fact that it was pushed aside from the mainstream of scientific investigation meant that it was on the verges of the scientific process as well, and it didn't have the same review process. And that might have been the end of it, except that the field of investigation continues to this day. Now, the field of research has had its name changed to avoid the stigma of cold fusion. It's now commonly referred to as low-energy nuclear reactions. Over this period, hundreds of labs have reported anomalous results while reproducing the work. Excess heat production, neutrons, fusion products turning up unexpectedly, using different metals and different protocols, but without an agreed scientific basis upon which to direct their work. It really hasn't amounted to anything in the mainstream. There hasn't been a successful commercialization. There hasn't been a reproducible system to come available to the mainstream. As recently as 2019, a team of Google and academic researchers published results of a replication attempt in a Nature Perspective article. So Nature is one of the biggest scientific journals reputable journals that can publish results. And these researchers identified previously unknown enhancements of fusion rates in a palladium wire at low energies, low being in the kiloelectron volts. Critics suggest, as I had mentioned, that the ostracization of the cold fusion community resulted in a pathological fear of being overly skeptical or critical of their work. Sloppy experiments aren't sufficiently criticized, and positive results are applauded without sufficient review, leading to a less than healthy scientific enterprise. But despite this, and despite the fact that the original experiment wasn't reproduced in full, there seems to be something there. Reproducibility of heat generation is being claimed by several labs and companies that are starting up to trying to commercialize this technology. A number of papers have appeared more recently in reputable journals with claims of excess heat, neutrons, and fusion products. There's a California company, Brilliant Energy, that have claimed to have developed a consistent method to produce excess heat energy near room temperature and are attempting to commercialize their LENR heaters. Their early work used proprietary shaped short electrical pulses, and it's been verified by an external lab, SRI International, which claimed heat production factors were measured exceeding a factor of 1.4 times the input energy. And that's a significant amount. The Brillouin work is based on a hypothesis called controlled electron capture. So this is their hypothesis, the inventor's hypothesis, whereby protons in the metal are purported to be forced to merge with electrons from the current pulses using their electrical pulse recipes. So the negative electron is forced into the positive hydrogen nucleus or proton, and they neutralize. Their charge neutralizes, they turn into a neutron. And this is something that physicists know can happen, but only under very specific conditions. And then these, what you would call cold neutrons, would participate in a fusion process with another proton and eventually create energy in a series of steps. So Robert Godes at Brillouin Energy, who's the founder, suggests this hypothesis. Protons in a metal matrix are trapped to a fraction of an angstrom in position under heat and pressure. A proton can capture an electron, become an ultra-cold neutron that remains stationary but without charge. That allows another proton to tunnel in and join it, creating heavier hydrogen and heat. Now, the proton capture of the electron is endothermic. It requires something like 730 kiloelectron volts of focused energy to be absorbed in the reaction. And that's one of the problems. So if this process is occurring, you get a deuterium atom, or a deuterium atom, which then goes to tritium to hydrogen 4. And hydrogen 4 is new to science. This is something that Godes is predicting is happening in his machines. And they predict this will beta decay to helium 4 in about 30 milliseconds. And this releases a whopping amount of energy. In fact, it's supposed to yield a 27 mega electron volt electron per atom of helium 4. Now, if it's beta decaying, that means it's emitting an high energy electron. These electrons should be detectable. 27 MeV is like close to the speed of light. It's going to shoot off in all directions. It's radiation. The proton-electron capture reaction is common in the sun and predicted by supercomputer simulations. It's the reverse of well-known free neutron beta decay. Don't have to know what that means. This process has its problems. The proposed process has been supposedly debunked by nuclear physicists. It seems impossible for electrons in the metal to actually get the energy necessary, 780 kiloelectron volts, to overcome the nuclear reaction barrier to start this chain of events. So Godes' idea that confinement of protons in the crystal lattice can boost the reaction rate quantum mechanically with his Q pulses or quantum pulses seems to be several orders of magnitude away from the expected confinement energies necessary for this to happen. Hydrogen 4 that he proposes doesn't exist. No one's observed this atom. So it's not uncommon for industries to commercialize processes that they don't really understand. This happens, look at anesthesia, look at pharmacology. The problem with any of those theories is that fusion energy comes out in big packets and should be easily observable. So what, if anything, is happening here? Are they really generating this heat, or is it a Ponzi thing? Is it real? Unexplained extreme conditions have been detected in nature. So we can't say for sure that we know exactly how all of these things might be working. There's a lot of unknown stuff that could be causing an effect, a nuclear effect. Lightning strikes, for example, create 5,000 neutrons per second per cubic meter. And physicists don't know how this occurs. Another potential contributor in this system is cavitation, or sonoluminescent, single bubble sonoluminescence. And in this particular thing, sonoluminescence, micro bubbles in a solution or in a liquid created in boiling liquid can collapse. And this collapse can emit X-rays. Spectroscopic studies on this process in using ultrasound to create these bubbles measured heavy particle temperatures and pressures of 15,000 Kelvin and 4,000 atmospheres in these tiny bubbles. And some simulations show that temperatures of up to 10 to the 8th Kelvin could be achieved for a duration of a picosecond when these bubbles collapse. And that's the sort of temperatures that they're making in tokamaks and laser fusion. So is there anything to these researchers' claims? There's several real physical mechanisms that could come into play beyond these more speculative ones. I want to touch a little bit on muon-catalyzed fusion. A 1956 New York Times article highlighted how electron-like particles with a large mass, called mu mesons, or now known as muons, could catalyze fusion between hydrogen nuclei with a heavier hydrogen nucleus to make a helium nucleus. And this process would then release energy. The muon can be shot at a bunch of these molecules and replace the electrons. And because it's so much heavier, it means the interatomic spacing is very much lower than it would otherwise be. And this overcomes the barriers, allows them to overcome the barriers and fuse at a higher rate. Physicist Luis Alvarez remembered the discovery of muon-catalyzed fusion during his 1968 Nobel Prize acceptance lecture. He was awarded the Nobel for bubble chamber experiments that he had developed and he'd used in muon-facilitated fusion way back. And this is what he said: "We had a short but exhilarating experience when we thought we had solved all of the fuel problems of mankind for the rest of time. While everyone else had been trying to solve this problem by heating hydrogen plasmas to millions of degrees, we had apparently stumbled on the solution involving very low temperatures instead." So reminiscent, right? But his team's excitement was soon dampened when researchers learned that the muons could only participate in a limited number of these fusion reactions before they decayed away. And the energy it took to make the muons was less than their fusion catalyzed reactions. So a beautiful idea squashed by ugly physics. Getting back to cold fusion and Pons and Fleischmann's experiment, the idea of loading metal anodes with deuterium is not as wacky as mainstream scientists make it out to be. The electrons in a metal can actually work to shield the electrostatic repulsion of atoms in the crystal structure and makes it easier for them to overcome the electrostatic repulsion of their nuclei. They end up closer together because of the electrons C in the metal. The electrons are negatively charged. The protons have this repulsion because they're both positively charged. So as you get closer together, the electrostatic repulsion of the positive charges would push them apart. But if they're bathed in a sea of negative electrons, this means they don't see each other, or they don't see the full repulsion that they would otherwise see. And in fact, they're attracted to a certain degree. So these forces could account for an increase of about 20 orders of magnitude over the baseline gas phase fusion rate. However, we need about 50 orders of magnitude increase over room temperature typical gas phase fusion rates to become significant. So what else could be happening? Well, phonons, vibrations in the metal itself due to heat, will actually cause the protons to be closer and further apart. And this oscillation is on a time scale that allows fusion to happen through quantum mechanical tunneling, which is a magical word that describes how this happens in quantum mechanics. And these vibrations can modulate the distance and give you another 15 orders of magnitude improvement. So now it's not looking so bad. Now we're only like 15 orders of magnitude away from working. Yeah, sure, that's horrible, but we don't know everything about what's going on here. Physics, similar to the work by the Google scientists looking at those fusion rates from low energy interactions in palladium wires, show that there could be actual nuclear resonances. There could be states of deuterium or hydrogen that are resonant at low energies that would increase the cross-section for these reactions to occur. And we just don't know what these rates are, or what these reaction rates are at low energies, because it's very difficult to measure. It's a difficult experiment to measure low energy fusion cross-sections, because fusions just don't happen very often. What does it all mean? It means that science, I think, has treated the field of cold fusion badly. Mainstream scientists associated with cold fusion were not allowed to publish in mainstream journals, and that means they would not be able to get paying jobs at mainstream institutions. They would not get research grants. They would not get respect of their colleagues. And there's something there. There is excess heat. Or I could be wrong, and these could all be Ponzi schemes. But it seems like the evidence is piling up that something is happening. It may not be fusion. We don't know what it is, but it deserves investigation, in my opinion. It's going to be my job over coming weeks to uncover the truth and determine what the evidence says. We're going to be interviewing some people that are associated with the research, some philosophers, to look at how science has maybe strayed from the scientific method, and hopefully we can steer it back in the right direction. Please stay tuned. Thank you for listening.
If you'd like to follow up with more in-depth discussions, please come find us on Facebook at The Rational View and join our discussion group. If you like what you're hearing, please consider visiting my Patreon page at patron.podbean.com/therationalview. Thanks for listening.